Good morning, everyone, and welcome to this webinar devoted to big data, cloud, computing, and artificial intelligence, especially for the automotive sector. So we hope that you can enjoy this webinar. So Bernard, please.
So thank you very much, Oyana. A very warm welcome from my side. Oyana is from Vicontech, a foundation in the Spanish automotive cluster. Yeah. And my name is Bernhard. I am from AVL, and we are very happy to welcome you to this workshop on the automotive topics. The idea of the workshop is pretty much similar to the idea of the whole automotive work group that we founded together with Vicontech by the end of last year. It's basically to bring two worlds together. On the one hand side, we have the cluster 4 world in Horizon Europe, mainly ICT players, the ones who are skilled in data science and data sharing and cloud and edge computing. So the horizontal technology players. And on the other hand side, we have the vertical players from the automotive field, from the automotive production field, CCAM area and automotive driving. So actually we want to a little bit play around with technology push from the technology provider side and application pull from the vertical perspective. And therefore, it's a pleasure for me to welcome you to this automotive workshop. And we have a very dense program for today. And therefore, it's a pleasure for me to announce our first speaker who will give us some opening remarks. It's Riku Leppänen. I hope the pronunciation is right, from the European Commission. He is program officer in DG Connect, Unit G1, and he is responsible for data policy and innovation. I therefore hand over now to Riku and look forward for his opening remarks. Riku, the floor is yours.
Thank you very much, Bernard. So indeed, I also want to thank Oyana for giving me the opportunity to be here. I'm like Bernhard mentioned, I'm a program officer in data policy and innovation units of DG Connect. And I also work as a project officer. And indeed, I was a PO in the very successful Cloud LSVA project. That's how I know Oyana very well. This Cloud LSVA project was for me in a bit of an eye-opener also for the challenges that data present to automated driving through the data annotation and labeling tasks, which are very, very labor intensive. And through this project of semi-automation, this task, it certainly has shown that these tasks can become more manageable. So now in the automotive sector, the whole sector is now being disrupted by the electrification of the sector, and this is something that will be a challenge for the industry as a whole, and it is through cooperation of the sector that this can be dealt with, because this challenge comes from outside Europe, and it is only through good cooperation and certainly data sharing that we see that this challenge can be met. So it is predicted that driverless cars would collect several terabytes of data even per hour in the future, so that it is clear that data is the key to successful full automation. Now, in Europe, the European strategy for data sets the scene for the use and sharing of data in Europe. The European automotive sector is currently the most important economic driver creating prosperity. And in Germany alone, the sector accounts for about 20% of revenue. So it is important that this sector in Europe manages to work together to counter the challenges coming from outside. So it is for this reason that European Commission promotes data sharing. So the recently adopted Data Governance Act aims to set the framework for this by promoting the creation of common European data spaces. So these data spaces are sector specific, and automotive sector would be one such data space. So data sharing within the sector is crucial, but also data sharing between the sectors are also essential. This leads to higher productiveness within the sector, which leads to higher profitability and stronger sector as a whole. So there are two terms that are often mentioned when talking about data sharing, and this is interoperability and standardization. So in that sense, for the data sharing to reach its full potential, the data needs to be interoperable and standardized. This is for me a topic which I deal with through the standardization working group in DG Connect, where I am a member, and we currently work together with BDVA Dairo to carry out mapping exercise on the standardization activities of the industry. And what we want to know is not only what are the standards currently used or who are the actors, but what are the gaps. We have been doing this gap analysis for since the end of last year, and we're starting to get results. And I know that many of the BDVA members have already participated in this, and I think it's very important to be active when asked, and so we can pass this information to the annual standardization rolling plan exercise, which then helps to focus the work in this area to the right direction. So under the Data Governance Act, which was adopted by the Commission recently, there will be a European Data Innovation Board created, and eventually this will take the role of the governance of technical standardization and to enhance interoperability. But this might take a couple of years before this is up and running. So we have to carry out these exercises before that. And there will be other initiatives also related to standardization that will come to play before the Data Innovation Board is up and running. So I want to finish by saying that we are now in a crossroads between the Horizon 2020 program and the Horizon Europe program, and the data DEP program as well, Digital Europe program, and we expect the program Horizon Europe and Digital Europe programs to be adopted in the coming months or coming weeks even, and the first calls should open soon after. So and the first projects should be signed beginning of next year. So there will be many opportunities there for the stakeholders to participate. I hope you will be active as well, and so I would ask you to keep your eye on the future calls that will open soon through the funding and tenders portal. So with that, I would like to close, and I wish you best of success with this session, and thanks again for inviting me. Thank you.
So thank you very much, Rico, for your insightful talk and for your very valuable comments on the European programs. I am now, let's say, transitioning to, let's say, a series of speakers. Almost all of them are either consortial leaders from H2020 projects or other industrial consortia. And we will start with a very ICT-centric topic. Professor Matthias Böhm from the Graz University of Technology will be our first speaker. Well, we are involved in one of his projects with the name Daphne, which is actually a short form for integrated data analysis pipelines for large-scale data management, HPC, and machine learning. And therefore, it's a pleasure for me to hand over to Professor Matthias Böhm from the Graz University of Technology. Matthias, the floor is yours.
Awesome. Thank you so much, Bernard. As Bernard already said, this talk is on Daphne, a general project, but also a system overview, and then a little bit of connection points to the automotive industry. So in general, we are seeing a trend towards those more complex integrated data analysis pipelines that include not just machine learning training or scoring, but also longer pipelines for pre-processing, ETL, and then subsequent data analysis, combining that with the training of potentially complex machine learning models, plus high-performance computing and machine learning assisted high-performance computing. So unfortunately, today, it is still incredibly difficult to compose those complex pipelines and actually deploy them in practice, because unfortunately, the programming paradigms and infrastructure is largely disparate and requires boundary crossing between different systems. However, we see, besides this trend toward kind of those common integrated data analysis pipelines, we see that those different systems involved in those pipelines have quite a number of shared compilation and runtime techniques, as well as the underlying hardware and accelerators are actually converging as well. Unfortunately, at the hardware side, we have a couple of challenges to deal with. As some of you might be aware, we are facing the end of the node scaling, where in the past we could proportionally kind of scale down the size of individual transistors while keeping the power density constant by essentially lowering voltage and increasing frequency. Now, due to leakage current and threshold voltage, where we can't lower it any further, that's essentially led to a stagnating frequency. However, Moore's law still continued by essentially increasing the number of cores. And however, originally Moore's law was stated as the number of transistors per chip doubles every 2 years at constant cost. And as we go to smaller and much smaller feature sizes, approaching 5 nanometers, and right now, there are different definitions, 2 nanometers even. We see increasing costs, which makes it economically questionable. At the same time, just increasing the degree of parallelism has its limitations as well, because due to Amdahl's law, even a very small serial fraction leads to an upper bound of the parallelism or upper bound on the speed up that we might observe. So what it ultimately leads to is dark silicon. We will not be able to power the entire die at the same time, which again leads to a specialization. So if we can't power the entire chip all the time, we might as well build custom tiles into it that serve certain frequently occurring functionalities. So ultimately, it points towards specialization. So we see specialization at many different levels of the entire software hardware stack. Consider the scenario from general purpose CPUs and GPUs all the way to field programmable gate arrays and application-specific integrated circuits. So as we go from the left to the right, essentially, hardware devices become more energy efficient while requiring longer times of reconfiguring for new operations. So we have this trade-off space, and certain applications aim to specialize with custom hardware in order to make that more efficient. At the same time, we see additional levels of specialization in terms of data types, sparsity exploitations, and along the entire storage hierarchy. So ultimately, it leads to a heterogeneity, and that in turn leads to utilization challenges. Besides those hardware challenges, we are also facing, as I already introduced, productivity challenges, and essentially there's a lack of a common system infrastructure to execute those integrated data analysis pipelines. And that's exactly what the DAFNE project tries to overcome by building an open and extensible system infrastructure that allows us to execute those integrated data analysis pipelines with primitives for data management, query processing, machine learning, and high-performance computing. Now, we are very proud of a very diverse consortium we assembled here, coming from those different areas of data management, high-performance computing, machine learning systems, but also algorithmic research, as well as different domains, including the automotive domain represented by AVL. And while there are a number of hubs and centers of excellence, we believe that real advancements require really creation. So in DAFNE, we are really trying to build new system infrastructure to enable those use cases relying on integrated data analysis pipelines. To give you a flavor of those use cases, so we have, again, diverse use cases. One of them is the German Air and Space Center, where we are dealing with Earth observations. So based on the Sentinel-1 and 2 datasets collected by the European Space Agency, the DLR essentially hand-labeled with 15 exports per month, individual patches from 20K by 20K images. And those images for a single year are already in the range of 4 petabytes. And then the task is to perform a classification of surface covers, because different surface covers have different reflection properties of the sunlight, leading to essentially local climate models around metropolitan areas. And we want to build those kinds of models for the entire planet. In addition to that, we have use cases from semiconductor manufacturing, reliability testing, vehicle development processes, as well as, more generally speaking, ML-assisted simulations and those complex integrated analysis pipelines. So what we are really trying to build now is an initial system infrastructure that provides a domain-specific language to express those integrated data analysis pipelines, plus convenient APIs to plug it into existing workflows and integrate well with existing system infrastructure. And then based on recently more popular MLIR, which stands for multi-level intermediate representation, that ultimately compiles down to LLVM, we are building a new optimizer and runtime environment that allows to execute those integrated analysis pipelines with high utilization of heterogeneous hardware devices, including computational storage, FPGAs, GPUs, and really trying not just to decide which operation to run where, but kind of distribute data across all those different devices. And of course, we aim to also integrate very well with existing resource management and programmer models. Now, you might ask, what is the connection to the automotive ecosystem and economy in general? So there are multiple connection points. First, in our use cases and involvement with partners from the automotive environment, we've seen really those hybrid workflows that are integrated data analysis pipelines, including data pre-processing, time alignment of time series and videos that we are recording, various extraction and analysis rules, as well as ML-assisted high-performance computing simulations. So it's all about making the integration of those hybrid workflows really seamless and allowing to execute them with high utilization of the hardware. At the same time, having this global view over the entire analysis pipeline in a single system allows us to perform various optimizations. So for example, often we deal with really thousands of irregular time series. To perform analysis, we have to subsample and bring them in a homogeneous form to actually view them as aligned observations. However, there are opportunities, if you're only interested in analyzing certain events, to push down part of the analysis into those irregular time series, allowing higher accuracy at much lower cost. And in addition to that, there are plenty of scenarios of kind of combining the actual training process with the pre-processing, for example, for data augmentation to build better models. And as Rico already mentioned, kind of federated learning is usually important in terms of addressing aspects of data sharing. So there's a recent trend toward federated learning and federated analytics in general that allows us to train multi-site machine learning models without central data consolidation and pushing in a privacy-preserving manner things down to the individual sites. This is closely related also to heterogeneous hardware, because if we have heterogeneous devices, we can cast the training process in similar to a multi-site learning process into a multi-device learning process. So the hope is to reuse that infrastructure there too. With that, I'm already at the end. I'm looking forward to discussions. Thank you.
Thank you very much, Matthias, for this very condensed information. Yeah, actually, you have saved some time and gave us the opportunity to discuss a little later. As said, we will continue with a series of talks, and then I will open the discussion. So it's a pleasure for me to hand over to our next speaker. With the nice name Evolve. So we are switching now from Austria to France, to Paris. Our next speaker is Jean-Thomas Acquaeva from DNN Storage, and he is the consortium leader of the Evolve project, which is an innovation action in the H 2020 framework. Evolve is a short name for abbreviation for high performance computing and cloud enhanced testbed for extracting value for diverse data at large scale. So Evolve immediately, let's say, continues some of the ideas that Matthias has brought up, and it is focused on large scale data sets. So Jean-Thomas, I look forward for your contribution.
Thanks a lot, Bernard, for the introduction. And thanks also for giving me the opportunity to present Evolve. So this H 2020 project, quite large, 14 million euro, 19 partners. So I'm the project coordinator, but the project is from a scientific standpoint overseen by Angelos Bilas from FORCE in Greece. So when we start the project, we saw that we could think a bit about the past, and what we have here, it was an application as seen in the early 2000s. It's no longer the case. So modern applications now are more like workflow. So it means it's an orchestrated software component, and each of these components has a very specific characteristic in terms of hardware requirements. So typically you can start with a data curation part where you need a lot of bandwidth to bring the data in, and then there is regular operation, for example, to curate the data, to calibrate the data. And here, for instance, FPGA would be great if it's about, signal processing, for instance. And then we can have a machine learning part, which is more suitable for GPU. And then we can have also interaction with a software component for numerical simulation, which is more like double precision floating point, and the visualization of the result and so on. So each of these components has a very different hardware footprint. So obviously, the platform, the most suitable to handle this kind of workflow is heterogeneous platform, which means that we have a processing unit, so this nice yellow square, and some of these processing units are augmented, accelerated by some specific hardware accelerator. So it could be GPU, it could be FPGA for the processing, but it could be also the addition of some local storage. So the ability for the node to store maybe a couple of terabytes locally with a very low latency. And the data lake is no longer a flat storage. It's also a tier storage where there is a part on flash with a high response, high bandwidth, low latency, but limited capacity. And for large capacity, like satellite images, for instance, or archive, then we go to the disk-based storage. So it means that some of the traditional...
Jean-Thomas,
yes?
Sorry to interrupt you, but we are not seeing the screen in full mode. So on the presentation mode.
Okay, so thanks for interrupting me, yes. Okay, so maybe I'm going to go this way. Stop share screen. Is it better? Sorry, no, it's smaller.
Well,
but...
wait a bit. Now it's in Austria. Yes, it is. Now I'm seeing it. Thank you.
Okay, sorry about this. So my speech was a bit decorrelated. So the modern workflow, the view of a heterogeneous platform. And this heterogeneity also, it's not only about hardware, it's also about software. So since we have heterogeneity at the hardware level, we need also to bring together a different software stack. And for instance, here on this view, I've stole this slide from the BDEC. So you have the HPC software stack in blue and the big data one. They share the same groundwork, Linux, but they have been built iteratively in completely independent way. A lot of work that we did in Evolve was to build bridges between some of these components. So for instance, the ability to run a Hadoop application, and we remove the slow HDFS part, and we plug directly Spark to a fast layer on the HPC. So somehow we reduce the number of software layers in order to accelerate the processing. So when I say we built, it's there is a physical object. So it's a view of the cluster that we have in France. It's hosted by Atos. And we have also some result already, because the project is almost 2/3 of his time now. So here this application is from maritime surveillance, from space HELAS. And from the beginning of the project to now, we have accelerated the application by more than a factor of 100 by applying this concept of heterogeneity to the workflow. So this application of maritime surveillance is coming from a set of use cases which are focused on satellite images. But we have also another big component in terms of use case that we use to validate our approach. And this other component is on mobility. So there is four or five use cases coming from mostly the automotive industry. And I would like to spend a few minutes talking about this one from AVS. So here the idea is to perform predictive maintenance on engine. So it's a bit complicated from a software standpoint, because we need to have a model of the engine. So there's a lot of numerical simulation involved. And also we need to compare this model with data which are captured by a lot of sensors in the engine, and not on sometimes even outside of the engine. So we can have some mechanical information about how the engine is behaving, the pressure in the cylinder, the rotation of the engine and things like that, but also some external factor like whether it's rainy and things like that. So we cross-correlate all this information. They are stored in a fast time series database. And this correlation of the sensor is compared with the model. And as soon as the divergence appears, it's a hint that a failure may occur. So this use case is quite interesting for us, because this is really, I will say, it's crystallizing the convergence between HPC, big data, and cloud. So big data, I mean, the amount of data that the sensors are bringing in is not negligible. So we are talking about tens of gigabytes per day. So it's, I mean, you need a serious configuration in order to handle this flow of data. It's HPC in the sense that we are doing predictive maintenance. So we need to be able to predict the failure before the failure arrives, right? You know, otherwise we lose. So there is some pressure to have a fast result. So here we need really the HPC capabilities of the platform. And it's cloud as well, because we want to have the ability to keep this kind of DevOps iterative loops from the workstation of the developer to the production. So we want to be able to deploy the application seamlessly from the local desktop down to the cluster, to the fast cluster. So everything has been containerized. So the workflow is not a single container, it's many containers which are linked together. As a result, I would say, of course, it works. Otherwise, of course, I will not have presented this slide. We have a nice speed up. So we improve the time to result by a factor of something like 50, which is not negligible. And when I say that we have a nice result, it's not only about performance. So it's not just going faster. Also, it's more efficient. So what is important here is that it's not HPC per se, or what we want is to have the fastest response. What we want is to have the most efficient production. So we need to keep the engineering in the loop. So this is why there is this emphasis on cloud. So what we provide in Evolve is a way to orchestrate a container in kind of very synthetic way. There is Carvadash, which is a framework that we have developed in the project, open source, to orchestrate the container. And we have also integrated or work with a notebook named Zeppelin, notebook technology. So the idea is really to bring efficiency, not only speed. So in terms of business, I think there is an important differentiation here. So just to conclude, I would say that our containerized approach, mostly relying on open source, it's providing good results. So it works well on heterogeneous platform. It works well within the data center. So now what we would like is to extend the reach of the technology to outside the data center. So to be able to interoperate with other data center, and more importantly, with the edge. And I think it's very important for the automotive ecosystem, they interact the edge with the data center. So that's my last slide. Thanks a lot for your attention.
So thank you very much, Jean-Thomas. Yeah, thank you very much. As said, questions will be asked afterwards. Just here, because I have 2 minutes left, because all of our speakers are disciplined in terms of time. Feel free, please, to post any kind of questions. Yeah, after the talks, we will go through the questions. Of course, you can also raise your questions afterwards, but if something comes to your mind, feel free to post the question into the chat. We will analyze the chat and then hand over and try to the questions to the speakers, or try to answer your questions if it's general questions. So let us continue with our automotive program. So next talk goes to the Basque country. So I have the pleasure to guide this automotive group together with Oriana from Vicontech, and she is our next speaker. She will talk about the project with the short version is Cloud LSVA, and LSVA stands, this project is an acronym for Cloud-Based Large-Scale Video Analysis for the CCAM, and CCAM is actually an abbreviation for Connected, Cooperative and Automated Mobility. Yeah? It's very prominent in the cluster 5 topics. So Oriana, I very much look forward to your talk.
Okay, thank you very much, Bernard, for this kind introduction. And as you have already mentioned, I am going to talk about Cloud LSVA project, which is cloud-based large-scale video analysis for CCAM. I would like to start with the problem that we wanted to solve when we start preparing this project. So we have been talking about a lot of big data problems and the general problems of cloud computing, but a specific application which demands a lot of data is the automotive sector. And especially when validating advanced driver assistance systems, we need to cover a lot of kilometers to enable or to validate these kind of applications, which require a lot of data to be treated and managed. So the advanced driver assistance system as the automated driving functionalities that brings extra comfort to the drivers needs somehow to pass a lot of testing and validation processes. And these systems and these validation processes are somehow complex because they need to ensure that all the systems are working properly in every single situation that they need to face. Because at the end, in the driver assistance, they are assisting the driver, but if they are doing the automated driving function, they are doing the driving function as a driver themselves. So the validation process is somehow tedious and is getting more and more complex, especially with the new NCAP validation systems. The thing is that here we are facing new sensors. We are facing cameras and LiDARs provided input. And this data is somehow very specific, and it's difficult to deal with because it is an image, it is a point cloud that we need somehow also to annotate, and we need to somehow get kind of information that they are getting in order to ensure that they are working properly in the pipeline of these driver assistance systems or automated driving function. So also it is noted to mention that the data that generate this kind of sensors is huge. So a vehicle equipped with a couple of 4 cameras and a LiDAR could generate 4 petabytes per day. So just giving through recording this data and analyzing this data is a huge effort. So as I was mentioning, the self-driving is a very hard, complex ecosystem. And when we are dealing with automated driving functions higher than 3, where the system has the control of the vehicle, we need to ensure that the system can react to the complexity of the world, to the unpredictability, and to the hazards that they can face. And also we need to ensure that we learn, or we make the system learn something that for us is usually very easy to understand for a human, but not for a machine. And this makes a really complex situation where we need to pretty much analyze and combine together the data and the AI functionalities. Again, making some kind of notes to how this is validated and how this is tested, we have different views of what they usually test in there. Okay, so we have the NCAP star rating that you all know for every vehicle, where the systems need to somehow face 450 tests on proving grounds. So we need to run 450 tests and analyze all the data generated by all these LiDARs, cameras, and functions. But this is not enough. So each OEM have a specific market differentiation where they want to test and validate the system on another topics and on open roads. And for that, the number of kilometers that they drive depends on the OEM. But recently, they have been approved that for next year, new legislation come, especially for those assisted driving functions, touching almost the automated level 3. And for that, just for doing the type approval of any L3 system, there will be required more than 1 million test runs between proving runs and virtual validation, which means a huge amount of data to be treated. So when we started this project back in 2016, we start dealing with this problem because it was already in the market. So we have Valeo and TomTom dealing with huge amount of data that they need somehow to annotate and to extract all the information to go through the pipeline. So we generated a consortium to deal with all this problem. So here is the usual way of doing that. So you have a vehicle equipped with all the sensors, do the recording, and then post-processing generally manually. There is a labeling of this data in order to design or validate the autonomous driving functions that you have under test. Usually, in order to scale up a little bit this process, usually the data that comes from the vehicle is uploaded to the cloud just to provide this scalability of the systems and to provide the possibility of being annotated by different persons who are in different locations. However, still the problem is large because we can collect more data than we can annotate manually. And this is a huge problem because we have a lot of data that is not being used just because we don't have enough resources to annotate that. So the Cloud LSBA project wanted just to somehow speed up this process by speeding up the capability of automatically annotating this data. And for that, what we did is just choose AI algorithms and the scalability of the cloud to deploy different pipelines of data analytics based on AI to generate automatically this labeling that was usually done by the humans manually. So this is quite challenging because the same data that we use for, or that need to be used for training, it is used for validating. So it has, or it is a closed cycle with an update of the algorithms that are doing the annotation, because not always we do need the same annotation type. So the thing is that putting this cycle in the pipeline of data processing, what we did is speed up the time required for doing this annotation. And we save up the 70% of the time required for annotating the data. But another important topic to be taken into account is the data format. So the data format based on an image is that we do not need only to deal with objects. We need to validate a driving function. We need somehow to also get the information about the events, the relation about the objects, and how they are behaving on the image. So the thing is that there was not such a data type or metadata formatting in there. So we generated a metadata format, which is a BCD, so that we could annotate events, relationship, and semantic context for enabling rich searching process. And with that, we have the complete system there, or the complete situation that is in front of us, seamless described with this data format. And again, for validating, we can go and record a lot of data and do this annotation, but perhaps if we combine properly this with synthetic data, we could speed up the validation process. The only thing is that the synthetic data and the system that we generate should be representative of what is happening in the real world. And for combining that, thanks to the BCD format, where we can somehow describe very precisely what is the situation ahead of us, we can then speed up or generate the same situation in the simulation domain, where we can play with weather condition, light condition, and speed up all the process of validation. And this is the final view of our system, where we, thanks to the BCD, we can generate this synthetic data scenario, and with this synthetic data, we can also do the validation. My final remark goes also to something that Riku has just mentioned in the opening statement, the need of standardization in order to be able to share and to validate homogeneously all the systems. So therefore, in the last year, we have been working with ASAM, which is a standardization body for the automotive domain, on trying to broaden their simulation-based standards there in order to cover the complete pipeline of the automotive domain from real-world recordings into the simulation interfaces for simulate all the situation and all the scenarios. And this is crucial if we want to share and have an homogeneous way of testing and validating the systems. Thank you very much.
So thank you very much, Oriana, for all the insightful information from point of view of automotive industry. You feel that we are more and more now transitioning to the verticals regarding the project. Yeah. Let us not lose time and continue with our next speaker. And the next speaker is Stepan Reha from Ertico, and he will talk about the ARCADE project, which is a short form for aligning research and innovation for connected and automated driving in Europe. Actually, I think this is not the short form of the project, to be precise here. This is just the title of Stefan's talk, but he can, of course, clarify that. So, Stefan, I very much look forward to your talk.
Okay. Good morning. Thank you, Bernhard, for the introduction. So I would just like to indeed mention that I'm indeed coordinating the ARCADE Coordination and Support Action, which is funded by the European Commission. And I'm also a member of the CCAM Partnership Executive Group, leading the Cluster 7 on coordination. That's why in my talk as well, I would like to make the link here with the CCAM Strategic Research and Innovation Agenda. So I will present about the views and the importance of data sharing in CCAM, so in connected automated mobility, and in particular about lessons learned and the outcome of a data sharing workshop that ARCADE recently organized. So the ARCADE project, as you mentioned, focuses on supporting the coordination of research and innovation in CCAM in Europe. One of the tasks there was to set up a European-wide knowledge base on CCAM, which is meant to be a one-stop shop for all activities related to CCAM in Europe. And the knowledge base contains one section dedicated to data sharing, to a data sharing framework, actually, which has been developed since the FOTNet projects and extended to automated driving within the Cartre and now the ARCADE projects. So the aim of this framework is to support projects and organizations by giving hands-on recommendations in different topics to enable reuse and data sharing. The framework is focused on field operational tests or naturalistic driving studies, but it has proven to be useful, although with slight adaptations to as well other domains. It is meant to be reviewed this year, and you are all welcome to provide comments or propose changes to the content. There is a link to the knowledge base here at the bottom, and there you can find a feedback form to provide some content and some feedback. Okay. Sorry, I clicked on the wrong button. Okay. One of the objectives of the workshop we organized was to support in particular the work of the CCAM platform, which has been set up by the European Commission, and in particular Working Group 2 on the coordination and cooperation of research and innovation and testing activities, and as well the CCAM partnership, which developed the strategic research and innovation agenda, which sets the priorities for the work program of Horizon Europe in CCAM. The background of, or in particular, the challenges that we are addressing there is that testing is really essential in CCAM for further technology development and assessing safety and performance of the technologies, but as well to analyze the impacts. And there are a lot of diverse tests ongoing across Europe, and that's why we need coordination. We do have harmonized approaches for the evaluation of the results, but as well to share data between the different projects. There are significant resources today spent in collecting the data, but not much is generally left to really analyze or reuse existing data sets. As also Hannah mentioned, I mean, very often there are not enough resources to go on with that. And that's why the Working Group 2 of the platform in particular is looking into facilitating data sharing of tests and as well identifying the challenges, priorities, and requirements for European test data sharing framework. Similarly, in the CCAM partnership in the SRIA, we have two clusters dealing with that. So cluster 5 on key enabling technologies is looking at the overall data sharing aspects, while cluster 7 is more looking into the test data sharing framework and the research and innovation priorities that are associated to it. So what is the landscape for data sharing today? There are many positive initiatives on data sharing in clusters, partnerships, and platforms. I will not go into details of these different projects, as you probably know many of them. So on the left here, there are more the overall data sharing approaches or platforms. But on the right side, there are two specific examples, which we looked more into that during our workshop. I would like to highlight in particular here the road safety data ecosystem, or SRTI, which is one key component addressing road fatalities and accidents in Europe, with information on 8 different traffic incidents that should be shared free of charge with the end users. In the SRTI ecosystem, a cooperative and decentralized approach has been set up, and they have produced a very interesting report, which can be accessible on the link that I provided, which I definitely recommend to have a look at. We also discussed in the workshop the edge computing advantages, because it has the potential to eliminate many issues with transferring personal data to the back office. Therefore, it's much more safer in terms of data sharing. In the workshop, we as well looked at experience from several large-scale projects that have been running in the area of CCAM, and each of the projects provided some best practices or experience that they have and lessons learned. One of the projects was the U-Drive project, which is a naturalistic driving study that was running from 2012 to 2017, although the analysis of data continued until 2020. There, they have implemented an online monitoring tool in order to really monitor and track the data all across the different value chains, and to keep the full control over the data. They also used an iterative approach. That means that they really worked with the raw data in several iterations. There was no pre-processing, and that was very much appreciated by experienced analysts. In the Autopilot project, which is about the usage of Internet of Things technologies to enable and enhance automated driving functions, there they defined logging guidelines, as well common data formats, file format, and naming to improve the productivity. And they recommended to ensure really a good communication between the data collection sites and the analysts, and as well to automate the data validation process as much as possible to ensure good quality of the data sets. Another very interesting project we looked at is the L3 pilot project, which is a large-scale pilot flagship project for automated driving, which up to 12 car manufacturers involved. And there they developed a common data format in order to facilitate the sharing of data, and this made it possible to commonly work on only one tool chain. They recommended to initiate the data workflow discussions very early, even prior to the project start. And the efforts to get to this common data format should not be underestimated. But with this approach, the project really achieved a level of data sharing which was much higher than previous projects. We also looked at principles for industry data sharing, again looking here at lessons learned and best practices from different initiatives, including the Invited EVE project, the Streetwise projects, but we also looked at, or there were recommendations to look at other initiatives like the safety pool and as well the NHTSA automated vehicle test framework. For every project, it was recommended that conditions for sharing should be clarified really at the start of the partnership. And it's very important to publicly disclose what data is or will be collected in the project, and therefore to inform as well the data user about why the data was gathered and what the data can be used for. For the vehicle domain more specifically, for anonymization, it's good to translate raw data into scenarios and label driving sections. However, for a full system assessment, more information and data is needed. So the complexity here is to really get this trade-off between pre-selecting the signals and the data within the car, and as well the risk of eliminating future research questions. So it's clear that the reuse of data is probably only possible within limited use cases, or at least, let's say, families of use cases. We also discussed a lot about the privacy of data in accident videos, but this data is arguably more important for safety research. And the one idea that was also discussed is that what to do when you have some findings in your analysis that impact public safety. And here there was an idea maybe to look at an approach similar to software vulnerability exposure, the CVA, that could be used here as well. The last part in our workshop was dedicated to more data sharing in research, and as well the limitations or the problems arising through GDPR or the General Data Protection Regulation in practice. We heard actually from several projects about scenarios where other parties in research are reluctant or refuse to share the data, citing GDPR as the reason. And however, really the purpose of GDPR is not to stop personal data from being shared. It's really to share such data in a manner which aligns with the principles of data protection and protects the privacy of individuals as much as possible. So some of the conclusions that we reached here and recommendations was that it would be good to set up regulatory sandboxes in order to test material and data collection before it is actually put into work. So here it would be good to have also that authorities support the setup of data collection experiments and provide feedback. That would avoid indeed setting up something that might get fined afterwards. Another very important aspect is the participant consent, or in particular the consent chain. So the data subject should be in control over where, who, when, and for what purpose that data is being processed. And it's important here to introduce a process for communicating the updates with regards to processing the personal data. We need to formulate an easy and understandable approach for organizing the participant consent and as well the whole chains. We also addressed the research exceptions to GDPR because that's really a topic of much interest, but that is not really well understood. It's underutilized at the moment by academics and researchers because there are exceptions from and are different from countries to countries. There is little practical guidance on as how these expectations can be used. And it's a case-by-case basis. So the use of exceptions must be well documented and justified. So we also agreed that it's important to look further into that and maybe have a collection of practices in this field. The legitimate interest is something that must be taken seriously. So it's very important to prove and that your interest is legitimate. And this needs to be really well thought well in advance before the project starts. And then the last part we discussed is the data minimization or the deep fakes, usage of deep fakes in vehicles. That's a really promising approach to reduce sensitivity of data. It's not really anonymization because vehicles might still be identified, but it's a step closer. And the advantage of, for example, using deepfakes here could be that indeed you de-identify the person, but you can still use it maybe for video analysis and to see the behavior of the driver. So here it's very important to develop effective and efficient measures for de-identification. I think that's more or less all for this workshop. I mean, we also concluded, indeed, as was already said before, that it's very important to work on standardization of metadata, for example, for the operational design domains, for scenarios, for functionality and services, and then as well to define an approach for balancing between public interest and industrial confidentiality. So it's very important here to enable the stakeholder dialogue. So that's it for my presentation. I'm looking forward to the discussion. Thank you.
Thank you very much, Stefan. Really very, very insightful talk. You mentioned exactly the pain points that we are thinking on night and day here. I very much look forward to discuss with the audience and with you. And at this point, I'd just like to mention that we will provide all the slides from our speakers after the workshop, of course, yeah, in terms of pain points and also in terms of proposed solutions. I think lots of fruit for the discussion afterwards. But between the discussion and now there is one speaker left, yeah, and it's our last speaker in this sequence. We go back to the German-speaking world, to Volkswagen Data Science Lab. It's a pleasure to welcome Jalel Ben-Bouzid. I hope the pronunciation is right. And he will introduce the ETAMI project, which is a short form for a very important topic, the ethical and trustworthiness aspect when it comes to artificial machine intelligence. Jalel, the floor is yours.
Thank you very much, Bernhard. I guess you all see my slides, right?
I see it very well.
All right, perfect. So yes, I am Jalal Ben Bouzid, and I work for Volkswagen Group, in particular in the Machine Learning Research Lab as a research scientist, and I'm also currently coordinating a consortium called ETAMI on ethical and trustworthy artificial intelligence. Hopefully I will explain all what I'm saying right now. We have all seen these flow of headlines in the news. Basically, every second day, there is a new controversy involving the deployment of AI technologies and some ethical issues around it. Recently, Capgemini did a executive survey, and they come up with the with the following insights. Basically, people are saying they don't know how to deal with these issues. They have no resources for that. There is usually pressure to finish projects on time or not too late. So it creates basically a prioritization, which maybe should not be the right prioritization. And basically there is a big gap between what academia says or what academia is talking about and what's happening in the industry. Also by the same institution, another survey showed that between 2019 and 2020, there has been an increase in awareness on these issues, and the executives are currently more aware of the importance of having transparency in the systems and the importance of working against the bias and discrimination in our systems, as well as the importance of explainability. But did it actually translate into practically implementing ethical considerations in these systems? I would say not really, because we still see a big flow of incidents. Actually, there is this amazing work by Charlie Parnell, where he is listing the incidents, and we're currently having something like almost 600 incidents listed in this database, and it keeps going on and on. Another reason why I think things are not changing fast enough is also essentially simply the perception of the public. And the recent Edelman report on trust showed that technology dropped down from the first position last year to the 9th position this year. So basically people are losing trust in this technology. And then the question that might arise is, are the automotive actors concerned? And I guess we all agree that yes. So we often see this depiction, which basically goes like autonomous or connected cars are just a smartphone on wheels. Well, to some extent, this is true, of course, but every comparison has its limitations. Of course, connected cars are filled with sensors. They also provide new types of services like voice recognition, and they incorporate also vision systems. But it's not the end of the story. Connected cars, unlike smartphones, cannot afford being sluggish, for example, or slow, or having failures, or just crash and be randomly rebooted. So it's like a highly reliable computing system, which, by the way, has also to process a big amount of data coming from all the different sensors. And very importantly, also, this huge computing machine has to be parked and left alone for some time. So it raises a whole new set of questions as for the way the data is processed, of course, but also cybersecurity questions and other ethical considerations when, given that this car is going to access so much private data and be interacting with our lives in a kind of constant basis. All right, so how do we implement trustworthiness? Basically with three things: regulation, with independent auditing, and good AI practices. On the regulation side, the European Commission recently came up with a proposal, and it's already a great first step. The proposal, as you may all know, defines, well, first it defines what AI is, and then if your product falls into the AI category, then the next step is to define whether it falls under the low risk or high risk category. And it's interesting because it's a first step to put a legal framework around the AI practices while trying not to hamper innovation. Third-party auditing is also important, but why third-party? It's because trust is in fact, a tripartite relationship. So if you have an AI producer, AI auditor, and the users, in order to prevent a conflict of interest, the users should not rely on the producer to serve or sell the product, and also assures the trustworthiness of it. So there should be a third actor which does the auditing and certification to the AI producer, and this actor is the trusted party by the users. I'm going a bit fast here as I was told I only have 10 minutes, but I hope there will be questions that I can answer later. Again, on the trustworthiness, there is this recent paper that was published, which actually makes the case for institutional trust. So for other industries like the aviation industry, essentially the users trust more the ecosystem and the certification system around the product than the product itself. So if we take the plane, what we trust usually is the regulation, the certification, and all the mechanisms that ensure that safety is preserved. And perhaps AI systems should also follow the same logic here. And finally, good AI practices, or more precisely, maybe good different risk management practices. So for traditional software systems, which can be described as we define the specs, and then we have a organization, developers, designers, whatever, who eat up these specs and output a function, and this function has desired output. Essentially, we know how to deal with the risks that comes with every step of the lifecycle. So for example, for specifications, we know that data validation and design patterns are very important. We also have developed agile processes. We also developed continuous integration practices, and so on. But with AI systems, what happens is, in addition to all these risks, there is a new layer of risks, which comes from the fact that there's a whole new component, which is data, essentially. And we don't know how to quantify the risk related to this data. It's big, hence big data, and we are currently trying to figure out how to deal with that. There's also new technological risks, and the fact that this technology outputs what's sometimes called black boxes also raises transparency risks. There is obviously new security risk coming with this technology. Things like adversarial attacks, but not only. We know today that people can recover data from the models that are deployed, that there is something called data poisoning, which can insert backdoors into these systems. And also, last but not least, because these systems are deployed in a society, then there is a feedback loop, because when you deploy a system, the system is going to output data, which is very likely going to end up in the input again. So there is a feedback loop here, and as you might know, any feedback loop exhibits the risk of exacerbating any small harm into a way bigger harm. That's why we launched the ETAMI consortium. Essentially, our mission is to make ethical and trustworthy AI something accessible and actionable. It is really at the intersection of all the topics I have mentioned so far, meaning what are the good practices for AI technologies, how do we instill ethical practices in the organizations, how to make them actionable, what are the standards that we should be actually implementing, but also auditing, which is a cornerstone of making these technology actually trustworthy, and of course the legal framework, the European legal framework. The consortium is consisting of 17 partners, 10 of which are from the industry, 7 are from academia. And ETAMI is European in its composition, so the partners are European for now, and it's also European in its content. So we actually take the high-level expert group on artificial intelligence report, the HLAG report on trustworthy and ethical artificial intelligence, and try to make ethical AI something actionable. So the HLAG report mentions 4 principles and 7 requirements. I'm not going to go through all of them, but essentially that AI technology should respect human autonomy, they should prevent harm, they should be explicable or explainable, and they should also ensure fairness. And we try to make that practical through the topics I mentioned so far, and in particular through algorithmic auditing. So in practice, what is auditing? Auditing is, simply speaking, tools, processes, and knowledge. So ETAMI focuses on each of these components. So we focus on documentation practices like fact sheets and model cards and data sheets, make them actionable, make them something which is concrete in practice, and define how they could be integrated into the process within organizations. We focus on security of AI systems, on explainability issues, on fairness also, and very importantly on actionable fairness, and fairness which is substantive in the sense that it's a fairness which is transforming and not just preserving the status quo. On processes, so we also work on defining how algorithmic AI auditing should be done, and how to document it, but also everything should also be in a kind of knowledge that is a sine qua non condition for auditing. And here, by knowledge, I mean what is the life cycle of AI applications, how to deploy applications in practice, and also knowledge about past incidents and how to learn, what to learn from them, regulation, of course, and mitigation, and so on. But also because by its nature, AI is a relatively young technology. So auditing is also a young subfield of auditing. So auditing AI is also a relatively young practice. That's why we also do innovation workshops to try to come up with novel ways of dealing with this issue. Almost finally, so just a bit of timeline. So we kicked off last November. We have been working on the methods for the last months. We're going to announce ETAMI publicly very soon, and also start to publish what we're doing and conduct internal pilots. And then at the end of the year, we're going to we're going to create an independent organization and open the organization to new members. If you have any question, please do not hesitate to reach out to us. And thanks.
Indeed. Thank you, Jalel, for your last words and for your talk and for your last word, because indeed we are coming now to the left space I'd like to devote to questions and answers. Yeah, while we are moderating the questions and answers session, I want to point your attention to 2 polls that we have kind of pre-compiled. Yeah. First, let's say there are 2 questions that we are using to stimulate the discussions. Question number 1 that is in the poll, and we are happy to receive some responses here, is, let's say, most of the talks emphasized, let's say, the potential that is opened when bridging the gaps between the horizontal or ICT players and the vertical or automotive players. Yeah, and we will be very happy to collect your ideas and opinions on this topic. Yeah, and the second poll that we have opened in the VOVA app is the very crucial issue that Stefan has announced also very, very well. It's data sharing. We highly depend in all the ecosystems, and this is a workshop on ecosystems, on on the data sharing ecosystem. And if you think on the scope of the different ecosystems from completely closed to completely open, if you think on the ways of sharing the metadata from distributed ledger technologies up to closed ecosystem where strong authentication is required and so on and so forth. We would like to have your opinions on that. Is it the case that open ecosystems should always use some kind of distributed ledgers and closed ecosystems rely on classical authentication, or what is the scope of dimensions that we need to bring into that discussions here? So that's regarding the polls. Let's now come to the discussion and questions and answers regarding our speakers today. I'm trying to look at the WOBA app, but I cannot access the questions and answers here, I see. So probably we do this in a classical way, and I will just ask you to classically raise your hand in the Zoom in order to let's say, answer your questions. Just Teilnehmer. Give me a moment. Oh, yes. So at the moment, we have a very shy audience, so please don't hesitate to raise your hand. So, well, in the meanwhile, I'm happy to come up with my question. And actually, my question is going, let's say, several speakers have addressed this, yeah, but the last two ones in particularly, let's say, what I was thinking on is the role of GDPR, yeah. Quite obviously, GDPR is a kind of, let's say, regulation that has the potential, the negative potential to hamper innovation. Yeah. On the other hand side, it protects the legitimate right of many customers. Yeah. That is particularly, I think, important in the B2C markets. So Stefan also mentioned this kind of regulatory sandboxes when it comes to data sharing. On the other hand side, we, let's say, have this restrictive regulations. What is, let's say, your opinion in how far is GDPR designed in a way that it has, let's say, the potential to trustfully share the data, or on the other direction to hamper the innovation, in the sense that if it's not optimally designed, if a regulation is not optimally designed, and we could later extend it probably to other regulations, then there is the risk that it is blocking innovation activities. Yeah. So who of the speakers probably is able to or is happy to answer this kind of concern that the kind of ambivalent relationship between GDPR and the restriction of GDPR and the role of innovation and the potential, the risk that GDPR is hampering or blocking innovation?
So as a storage provider, I would say that for us, it's we are facing the need to have public data sets. So obviously, specifically in health environment, for example, moving data around is very complicated, both for ethical and on the legal reason you were mentioning. But we can still proceed and work and innovate if we have a reliable data set which is publicly available. Mm-hmm. And I think this is the case in most of the projects. I have to say that up to now, what I've seen is mostly data set coming from the US or China. So maybe there is a bit of an effort here on our side to propose, I would say, European data sets. That would be my.
I spotted several opportunities. Thank you, Jean-Thomas, for this contribution. Actually, I spotted several opportunities in the talk from Ertico, yeah, think on safety-related accident data. Yeah? I think, Stefan, you had a slide on accident-related data, and if I'm not mistaken, you mentioned that this kind of data, at least there's some kind of intention to share this kind of data publicly. Yeah? Such kind of data might also contain private information. How is this kind of community that is pushing forward the publication of this data dealing with that?
Yes. So indeed, as I mentioned, the approach here is that this is complete. There is no personal data in this. It's really about sharing just information about incidents. There are 8 types of information that have been selected here, and it's really what is important here to say is that it's building really on this cooperative and decentralized approach. So you can only access the messages if you also contribute, and each participant in the systems really takes a defined role with obligations that have been clearly formulated. And I think that's really key in all this ecosystem. That means that you really, once you speak about sharing of this different data, you have to have the clear roles defined. And as well, I mean, nothing is really completely for free. There is a contribution expected on both sides. But definitely here, it's not about personal data, it's aggregated data, and it's only the information about the incidents that is provided in the end. And that's also what I mentioned in the general principle. It's always that there's this sort of trade-off that you need in the end to somehow cut it down to scenarios as well.
I mean, how can I gain trust in the fact that there is no personal data included? Yeah, we had some very, let's say, I would say rare, almost accidents, like for example, the size of the food of a worker in a factory, yeah, is a personal, it's a personal feature. Yeah, if this kind of information is contained in the data set, yeah, the stakeholder who wants to share the data in order to create, of course, some new kind of insights, yeah, it gives the data away in order to get some insight back, yeah, I got aware of this, and this is creating quite a lot of mistrust in the sense that the responsible manager feels that when sharing the data, he is somehow in a gray zone because there might be some data contained that is related to GDPR. So there's just some practical experience that I got aware of, yeah, and creating the framework in a way that the one who wants to share the data can believe or can develop complete trust that he's doing something completely legal there. That is very, very important, yeah. Because if you feel in that gray zone, yeah, you might not be very happy with the situation of data sharing, yeah. And I think technology should be able to support there. Yeah?
Yeah, no, that's why as well. I mean, I don't have all the details. I mean, I mean, I recommend to read this report that I provided the link to, but I know that there is really different levels in this process of this ecosystem with level 1 data and up to level 3 data, where they have the raw data that is really not leaving the vehicle. And then there's a first aggregation towards this SRTI messages, and then with aggregated message, and then there is really this creation of the service. And in the end, what is really shared here is really the warning about the incident.
I see. Yeah, it's about the value proposition in the data, what is shared. Yeah, I see. So thank you, Stefan. We still have a couple of minutes. So, and there is one question left.
Maybe Bernhard, maybe on the data very quickly.
Thank you, Jalal. Yeah, you already spotted the questions. Thank you.
Yes, but very quickly on the data issue on GDPR. Well, I'm not a legal scholar, so I'm not going to really speak from the legal perspective here. Although I believe all laws are imperfect, and that's how law is. And GDPR actually is an improvement on the privacy, on the data protection front, but it might be imperfect. Actually, it even hampers some research in science, but that's how it is. So we expect it to evolve, and that's how things are. However, I think one of the misconceptions about private data is that we don't really measure to which extent data can be identified. So we know today that I don't need to know much except for some likes on Facebook in order to infer a lot of private information about an individual, like, for example, political orientation, sexual orientation, or even things like whether, so the drink consumption of the person only from the activity on the social media. Same thing also holds for cultural preferences, like movie likings and music. So we can actually infer a lot of data only from these very simple features. That's one thing. Another thing is we don't know how the data is going to be used in the future. So, for instance, so the Netflix challenge that was organized in 2006, which showed that if I take an anonymized database of movie ratings, I can very simply go to IMDb and correlate it with another data set and de-anonymize a good bunch of users from the Netflix data set. So initially the IMDb data set was public. It was limited, but then in conjunction with the Netflix point here is that I think there is a discussion to be held here about what data is identifiable and how we deal with that. And I understand the worry from the user perspective that if I give away my data, what is going to be done with it in the future? So there's this kind of framing to be done here.
So thank you. I see. So thank you, Jalel. And there is one question from the audience that goes also in your direction. Let me just rephrase it from the chat here. One for Jalel, a question. I understood that the need to build ethical AI, but I suppose there is also an effort to frame ethical usage of AI. So to my understanding, the difference between, let's say, to build ethical AI from a technical point of view or from a methodological point of view, and on the other hand, you have the usage of this technology that can be unethical or ethical. Can you probably comment on that?
Yeah, very quickly. I think it's both, actually. I mean, the very reason AI is used for a particular case is something to be framed ethically. Do we really need AI for that problem? I think that's the first question one should ask. And then the impact of the AI technology, is there any, can we actually quantify the impact? Can we at least analyze? And of course, then the usage itself of the technology. So what data do we use? What models do we use? What technological choices do we make? All of these will influence the impact of the AI technology. So and by the way, it's not only in the data, it's really the choice of the technology itself, which can have a tremendous impact down the road. So I would say, yes, everything from the very design of the system to its implementation and then deployment.
I see. Thank you very much. Yes.
Sure.
Yes. I think it's a longer debate on that. Yes, that is. But I can share this point of view, definitely. Yeah. So as we are coming to the end, I would like to probably use the opportunity to comment on the polls on the sessions. And you remember we had two points of the polls. We had two questions. The first one was related to challenges when it comes to bridging the horizontal and the vertical interests of the stakeholders. Yeah. Well, and here we have three results to the polls. Yeah. So one participant says that it's critical to avoid silos between the different ecosystems. To prioritize the ecosystem perspective. Well, I can fully agree on that. It's not of use if the horizontal players and the automotive players make separate kind of data spaces without having a sustainable bridge between them. Yeah. Then another participant comments on the fact that automotive players want to enter in the ICT space eventually with non-interoperable solutions. So that refers also back to some of the speakers and to Rico's comment from on the very beginning. Interoperability is a very, very crucial issue to be solved besides of standardization. And then the last comment refers to the communication between the actors and the response capacity that each one has to interoperate with. And unfortunately, then the comment is over. So, well, I think I have to understand that comment first, and then we'll comment on that in the app. Yeah. And then regarding the data sharing questions, we had two comments there on the data sharing ecosystems. Well, one participant is saying here that SMEs already play a role in that. So I think in the design of this kind of data spaces, interoperability between the data spaces as SMEs are a major backbone of the European industry, of the European economic strengths. We should definitely have an open system and encourage them to participate in that ecosystem. Well, very good comment from my point of view. And of course, when it comes to, let's say, connecting the different data spaces, think in the automotive world, the mobility data space with the manufacturing data space or the energy data space, energy related data space. Then one participant was mentioning here that the use of protocols, through the use of the clearly defined protocols, we can use these protocols to bridge the gap, to connect the one data space to the other data space. That is probably the last comment, because our time is already over. We are just 1 minute over the time. So from my point of view, thank you very much for participating in this automotive workshop. I know that we had a very dense program. Not all of the questions have been answered now. Me and Oriana, we will go through these questions and try to answer it as close as possible, potentially come back to the speakers. Also, let me also thank our marvelous speakers today. They have spent a lot of time in preparing a very short slot. Each of the speakers has a very disciplined way in sticking to the time slot. So thank you very much for your contribution. We honor that a lot, and you contributed a lot today in bridging the gaps between the cluster 4 topics on ICT and the cluster 5 topics on automotive and CCAM. So all the best from my side, and my last word goes to Oriana.
Just to thank everybody, as Bernard has already said, it has been a very nice session today with a lot of very practical and very interesting information to be shared. So thank you very much for assisting, and we hope that you have also enjoyed the session as we have. So thank you very much.